Now, next we are going to solve problem 13 in the problem sheet. So consider the line r equals 2, 2 plus lambda 2, 1. This line intersects a circle with radius r equals square root of 2 and center c equals -1, 0 at 2 points A and B. Find their coordinates. My recommendation for these problems is always start by just drawing the situation, yeah? So let's start by drawing the origin in this two-dimensional problem. So let's say that the origin is here, and I'm going to draw the two axes, x and y. So this is our origin point. Now we have a line which is equal to 2, 2 plus lambda 2, 1. Okay, so we can say that this line is a point r0 plus lambda times a vector v. Yeah, so r0 is some vector. Let's draw it like this. This is r0. Yeah, and then v is a vector. Let's draw it here. This is our vector v, for example. So this means that our line looks like this. That will be our line. Next, we have a circle. And this circle has a center point, which is given by vector c. So let's draw vector c here. So let's say that the center of the circle is here. Yeah. So we have a vector c. And then it has a radius. So we can draw the circle like this. Not a very professionally drawn circle, but it should be good enough. So now the problem is saying that this circle intercepts the line at 2 points, A and B. Okay, so our task for this problem is to find these two vectors, A and B. So that's going to be our task. So how are we going to solve this problem? Let's start by writing the equation of the line. So the equation of the line is r equals 2, 2 plus lambda 2, 1. And remember, this first value is r0 and this second value is vector v. Yeah, so that is the line. So that is this green line here. Now, what about the circle? So the equation of a circle is written as modulus of r minus c equals r, where r, well, let's say equals a, where a is the radius of this circle. Yeah, so a would be this value here. So what does this equation mean? It means that the length of a vector that joins r, where r is any point in the circle, the vector that joins r to c, so that would be a vector that points from the center to any point in the circle r. Yeah? So this vector has a length equal to the radius. That's the definition of a circle. So this is the equation of the circle. So what we are next going to do is to solve these two equations, 1 and 2, simultaneously. So we want to find these 2 points, A and B, and we know that these 2 points will fulfill this equation, and at the same time, they will fulfill this other equation. Okay? So let's substitute r from the first equation into the second equation. So we start. R, we substitute the equation of the line. 2, 2 plus lambda 2, 1. So that is r minus c, which is the center of the circle, which is given in the question. So minus 1, 0. The norm of this subtraction is equal to a, which is the radius, which is given in the equation as square root of 2. Okay, so now we develop this expression. Basically, I'm going to calculate whatever is inside this norm. Yeah, so I'm going to add these 2 vectors. So this will be the vector 2 plus 2 lambda and 2 plus lambda. And then I'm going to subtract the vector minus 1, 0. And I want to calculate the norm of that. So let's do that subtraction. So 2 plus 2 lambda minus minus 1, that's 3 plus 2 lambda. And then 2 plus lambda minus 0 is just 2 plus lambda. So the norm of this vector must be equal square root of 2. So how do you calculate the norm of a vector? So remember, if a vector v is equal to vx, vy, the norm of vector v is equal to the square root of vx squared plus vy squared. And this is just Pythagoras' theorem. Yeah? This is the norm of v. So let's do the square root of the first component squared plus the second component squared equals square root of 2. Now let's square both sides so that we get rid of that square root. So we get 3 plus 2 lambda squared plus 2 plus lambda squared equals 2. Okay, and now we expand these brackets. Okay, so we have arrived at a polynomial quadratic equation. 5 lambda squared plus 16 lambda plus 11 equals 0. So now we know how to solve this. We need to solve the equation. So lambda equals minus v plus or minus the square root of b squared minus 4ac divided by 2a, where a, b, and c are the coefficients of the different powers of lambda. Yeah? So by doing this, we can find the two solutions for lambda, which are minus 1 and minus 11 fifths. So now that we know lambda, we just substitute this lambda into the equation of the line, and we will find our 2 points A and B. I'm not going to do it. You just substitute, for example, lambda equals minus 1. So then you do 2 plus minus 1 times 2 and 2 plus minus 1 times 1. And that will be one of the points. And then you substitute lambda equals minus 11 fifths, and that would give you the other point. The solution is on the notes. But what I do want to point out is the beauty of maths in this case. So notice how by using the equation of a circle, which includes squares, yeah, because it includes the norm, so you need to raise things to the second power. And this means that you ended up with a quadratic equation. And as you know, a quadratic equation, 3 things can happen. It can have 2 solutions, 1 solution, or no solution, depending on b squared minus 4ac. And this makes perfect sense geometrically, because when you have a circle and you have a line and you are looking for the intersection, you can either have 2 solutions, yeah, or maybe you have a line that touches the point at a grazing angle here, like a tangent, and then it's 1 solution of the quadratic equation. Or you could have a line that doesn't touch the circle at all, and that could correspond to the case of 0 solutions. So the different possibilities of the quadratic equation give rise to these 3 cases geometrically that are possible. So this solves the problem. Thank you very much.